students, how are you? I hope you all are doing great today. My name is Neenu Rathi and today we'll be learning our very interesting topic, that is Basic Geometrical Ideas Part 2. Now in this chapter we will learn about line, segment, ray, line, angle and its measurement, classification of angles, pair of angles, construction of angles, how we can construct angle with compasses, triangles, quadrilaterals and polygons. Let's start with introduction. Now in the previous chapter we have studied some basic geometrical concepts such as point, line, ray, line segment, angle and triangle. Now let's start with the line segment. A line segment is a part of a line. It has two endpoints and has definite length, no breadth, no thickness, and the length of line segment is a distance that can be measured in meters, centimeter or millimeters. Now 10 millimeter is equals to 1 centimeter, 10 centimeter, 1 decimeter, 10 decimeter, 1 meter, 10 meter, 1 decameter, 10 decameter, 1 hectometer and 10 hectometer is equals to 1 kilometer. So here P and Q are 2 points on a plane and then a straight line between P and Q is called the line segment PQ. Now the minimum distance from P to Q is called the length of the line segment PQ and P and Q are called the end points of the line segment PQ. Measuring line segment. We can measure line segment by using a scale. Suppose PQ is a given line segment that we have to measure. So to measure, we place 0 of scale at point P of the line segment, then see where the next point Q reaches. Now in this picture, Q crosses 7 centimeter marks and reaches 0.5 centimeter after it. So Q is at 7.5 centimeter. Now how we can compare two line segments? By establishing a relationship between their lengths, whether one line segment is greater than, equal to or less than the other one. So comparison is done in several ways. First is comparison by observation. Line segment can be compared easily by observation. That means placing a line segment below the another line segment and judging the line visually. Now the working rules are simple. In step 1, we will draw two line segments, we will label them, then we will place one line segment just below the another line segment and by observation we can compare both of these. For example, here we have to compare the two line segment by observation. So we can see that PQ is longer than AB, so PQ extends farther to the right of AB. Next is our comparison by tracing. One cannot always sure about visual judgments, but by looking at the line segment, difference in length of line segment may not be obvious, so we require better methods, and one such method is by tracing or by superimposing. Working rules are: we will use a trace paper to trace a line segment PQ, then we will place the trace line on the other line segment, and if PQ on the tracing paper covers AB behind it, that means it is longer, otherwise AB is long. Example number 2 says that we have to compare PQ and AB by tracing. So to compare PQ and AB line segment, what we will use a tracing paper, then we will trace AB and we'll place it on the line segment PQ. Now in tracing it is known that PQ is greater than AB. Now comparison using a divider. Now how we can compare it using a divider? In a geometry box there is an instrument called divider, and a divider has two arms hinged together. Each arm has one pointed metallic end and the distance between the two ends can be increased or decreased as required. Now let us compare these using a divider. Here are the working rules. In the step 1 we have said that we have to place the end point of one arm of the divider at A. Then we will open the divider in such a way that the end point of other arm reaches the point B. In step 3 we will lift the divider without disturbing its opening. We will place the end point of one arm at P. Hence there are 3 cases. First is the second arm of the driver falls on Q. In this case we can say that the length of both the lines are equal. In case 2, the second arm, if it falls between point P and Q, that means PQ is greater than AB, and if the second arm's pointed M outside PQ, that means AB is greater than PQ. Now let's start with example number 3. Here we have to compare the two line segments AB and PQ using a divider. Now we will place the end point of one arm of the divider at A. Then we will open the divider in such a way that the end point of the other arm reaches the other point B. Now we will lift the divider without disturbing its opening. We will place the end point of one arm at P and other at Q. Now on comparing we notice that PQ is greater than AB. Now let's start with the ray. A ray is a line segment which is fixed at one end and extended on the other end. So AB is a ray that starts from point A and keeps on extended in the direction of B. So here ray extension towards B direction and E is called the starting or initial point. A large number of rays can be drawn through a single point. For example, AB, AC, AD, AE, AF, AG, AH and AI, AJ and AK. Now we can see that rays starting from a fixed point like a torch or sun and others. Line. A line is extended on both sides endlessly. So a line AB is represented by a line on the name with arrows on both sides, that is AB. Now we can also represent a line using a small letter. For example, AB can be written as letter L or M. Pair of lines. When pair of lines are given in a plane, they may be parallel or intersecting to each other. Always remember, the word in the same plane should be carefully noted, and there can be two lines in two different places, not parallel and not at the same time, and they do not meet each other. Now parallel lines. Two lines in the same plane are not intersecting each other are called parallel lines. The lines AB and CD never meet each other, so they are equidistant from each other. Such lines are called parallel lines. So AB parallel to CD, and this is the symbol that represent is parallel to. Now next is our example number 4. Here we have to tell which of the line is a parallel line or segment. Here only first has a pair of parallel line segments. Second are the intersecting lines. Two lines that have only one point in common, intersecting lines. If the lines between the intersecting line is 90, then the lines are perpendicular to each other, and AB is perpendicular to CD, can be represented like this. Now let's start with example number 5. Here we have to name the pair of perpendicular lines in the following diagram. From the figure, AB perpendicular to BC, AB perpendicular to AD, DC perpendicular to AD and DC perpendicular to BC. From the figure, ML perpendicular to MN. Start with exercise 7.1. In the first part, we have to choose the correct option in the OMR sheet. How many parallel lines are there in the letter E? 3. That's how you can complete the remaining part. Let's start with check your progress. The adjoining figure represents a box. Here you have to answer the following question. Are the planes ABCD and ABEF parallel? Yes. That's how you can complete the remaining part. Angles. Now an angle is a figure formed by two rays come out of the same starting point. Now the starting point is called the vertex, and rays that form the angle are called arms or sides. An angle is represented like this. In the given figure, AB and AC are the two rays starting from point A and forms an angle. So AB and AC are two rays and arms of the angle A. Now let's start with measurement of angle. Now the measurement of angle or its size depend upon the amount of opening between two sides. Now in the given figure, angle ABC has a measurement denoted by B or an arc of a circle drawn inside this region. Measuring angle using a protractor. A protractor is a geometrical instrument that looks like the letter D, and it is used to measure angle and draw lines of required magnitude. Now the curved edge is divided into 180 equal parts. Each part is equal to a degree, so there are 180 degrees, and on the left side vice versa. Now let us follow the working rules given below. Here is the working rules that how we can measure an angle using a protractor. Now in the step 1, we will place the protractor in the midpoint of its straight line like this of the angle ABC. After that, we will adjust the protractor BC such that it is along the straight edge of the protractor. Now in step 3, there are two scales of the protractor. We will read the scale 0 and then make the coinciding the straight angle with ray BC. Now in the step 4th, what we have done, we have marked BA on the curved edge, and then we will find out the degree by measuring it. So angle ABC is of 60 degrees. Now comparison of angles. The magnitude of angle depends upon the opening and inclination between the two rays that forms the angle. Now if two angles have different inclination, then we can say that they have different magnitudes, and the magnitude of two angles can be compared in the following manner. First is comparison by inspection. That means more is the opening between two wires, greater is the magnitude of an angle. Now here we will observe the opening of two angles, and we can see that angle PQR is less than angle MNO. Now here we will compare by using the tracing paper. Now what we will do, we will trace an angle ABC on a tracing paper, then we will place it on the another angle such that if the vertex E falls on vertex B and then there are three cases arises. First case is when arm BA fall beyond D, that means angle ABC is greater. If it falls exactly on AD, that means both the angles are equal, and if arm BA falls between DB and BC, that means angle DEF is greater. Now in example number 6, what we have told that in the adjoining figure we have to find the largest angle and also arrange the angles in descending order. So that means angle AOB is greater than angle AOC, which is greater than angle AOD, and which is greater than DOB, and greater than COB, and then greater than DOC. Now let's start with the classification of angles. Here are our types of angles. Angles can be classified into according to their degree measures. Now first is our acute angle, when an angle measure is less than 90 degree. Here the angle is AOB's acute angle. Always remember, the magnitude of angle does not depend upon the length of its arm. For example, angle between two adjacent edges of scissor, sun rays making acute angle with ground in the morning. Now right angle, which measure exactly 90 degree. Now the arms of right angle are perpendicular to each other. So angle AOB is right angle. For example, corner of a room, pillar on the ground form right angle. Obtuse angle, an angle which is greater than right angle but less than 2 right angle, that is our obtuse angle. That means it measures is more than 90 but less than 180. Here angle ABC is an obtuse angle. For example, two adjacent sides of a microphone, set two edges of a book reading desk and two edges of the roof of a house form obtuse angle. Straight angle, an angle whose measure exactly 180 degree, that is our straight angle. In this figure, ABC is an angle extended opposite directions. For example, tube, light, pencil, line segment form the straight angles. Next is our reflex angle. A reflex angle is an angle which is larger than a straight angle. Its measure is more than 180 but less than 360. So this is a reflex angle. Next is our complete angle. A complete angle is formed when the revolving ray OP has made one complete revolution around the fixed point O after starting from the fixed initial position. So the complete angle is 360 degree. The minute hand of a clock, if it starts from point A and return back after complete revolution to the point A, that means a complete 360 degree is formed. Zero angle. Angle whose measure is 0, that means the two hands of a clock in the 12 o'clock before the start of any movement, 0 angle. Example 95 is an example of very good, that is obtuse angle. Pair of angles. Now such angles have special name according to their pairs. First one is adjacent angles. Two angles are said to be adjacent if they have a common vertex, that is the other two arms are extended on the opposite sides of the common arm. So angle AOB and angle BOC are adjacent, that means they have a common vertex O and common arm OB. So they are called the outer arms. In example number 8, we have to tell which of the following figures is an example of adjacent angle. So figure 1 has a pair of adjacent angles, linear pair. A pair of adjacent angles is said to be linear pair if the outer lie on the line and both the angles form linear pair as arms OA and OC are on the same line. Obviously, angle AOB plus angle BOC is equals to 180 degree and the sum of measures of a linear pair is always 180 degree. Now example number 9, we have to find the value of x in the adjacent figure. So here 52 plus x, so x is 128 degree as it forms a linear pair. Now always remember, complementary angles need not to be adjacent. It is only the sum of their measures which determine whether they are complementary or not. The complementary angles, two angles are said to be complementary if their sum of measures is 90. For example, an angle of 50 is complementary to angle 40. Each angle is said to be complementary of other. For example, 42 and 48 forms a complementary pair. Why? Because when we add, it gives us answer of sum of 90 degree. Now supplementary angles, two angles are said to be supplementary if sum of their measure is 180 degree. Now for example, 120 and 160 are supplementary because their sum is the complement of the other. Now always remember, the two angles which forms a linear pair are always supplementary. Like complementary angles, the supplementary need not to be adjacent. Now example number 11, 80 and 100 forms a supplementary angle. Is this the statement correct? Yes, because it gives us a sum of 180 degree. Now vertically opposite angles. The vertically opposite angles are the angles that are opposite to the common vertex formed by the intersection of two lines. So in the above figure, AB and CD intersecting at point O and AOD and COB are vertically opposite. So AOC and AOB are vertically opposite angles, and vertically opposite angles have no common arm. Now in example number 12, in the figure given and right, are the vertically opposite angles marked? Are they equal? Yes, they are equal. Angle 1 and 2 and angle 3 and 4 are vertically opposite angles as they are equal. Now let's start with exercise 7.2. In the first part, we have multiple choice question. Take the correct option. Which of the following is acute? 45 degree and 60 degree. That's how you can complete the remaining parts. Horse in the adjoining figure state whether angle CAB and angle ABD is a pair of adjacent angle. If not, why? They are the pair of alternate interior angles. That's how you can complete the remaining one. Construction of angles. To draw a bisector perpendicular to line segment. To draw a bisector on line segment, we will draw a line segment PQ of the given measurement if with P as its center, and then we will draw the arcs at point U and V. Now the radius should be more than half of the line segment PQ. Now in the same way, from the other end Q, we will draw the arms on U and V of same measurement. Now we will join U and V. Now U and V is a bisector of PQ and UO is at 90 degree. Also VO is also at 90 degree. That means that perpendicular is at 90 degree in the given line segment. Now how we can draw perpendicular on the given line of a given point of a line segment? Now suppose that what we have said, that suppose that PQ is a given line segment and O is a point on it. So to draw a line on point O that is perpendicular to PQ, we have to take the following steps. Firstly, we draw an arc of any radius keeping the needle at point O. Then we will intersect the line R and S point. After that, with the same radius, we will cut the arc of the semicircle by drawing arcs from the point R and then from the point S. Then keeping the needle off at A and B, we will draw arc at point C. Then we will join C with O, and this is our line perpendicular to the line segment PQ at point O. Now how to draw an angle equal to another angle? Suppose angle PQR is a given angle. Now here we have to draw a line segment AB of the length of QR. We will keep the needle of compass and draw an arc ST like this. After that, we will bring the needle of compass at point A and then we will draw the arc of the same measurement. Now we will keep the needle of at divider at T and then we will adjust the other end of the divider of the same length of ST. Then we will keep the needle at U of AB and we will cut the arc with same length of ST at point V. Now we will join A at B and here angle WAB is equals to angle PQR. Now to bisect a given angle, suppose PQR is a given angle, we will draw an arc ST keeping the needle of compass at Q. After that, we will draw same radius of arc ST. Then we will draw small arcs at point U from point S and T. Then we will join Q, U and extend, and here we have two angles which are equal to each other. Now how we can draw a line parallel to another line? A line segment XY is given. We will take a point Q on XY, then we will make an angle RQY, then we will draw an angle R on the same measurement RQY. We will join R and S and then we will extend it in both directions. Here is our exercise 7.3. In the first one, you have to draw a line segment which is perpendicular bisector to a given line PQ of 4 cm. So what we'll do, you will first draw a line segment of 4 cm. Then after that you will take a compass and then you will draw an arc here, then another arc here, then again one arc here and another arc is here. After that you will join it and this is the perpendicular bisector. That's how you have to complete the remaining part. Next is our construction of angle with compasses. First is we have to draw an angle of 60 degree using compass. Firstly we will draw a ray. After that at point A we will cut AB at P. Then we will place a needle of compass at P with the same. After that we will cut the first at point Q. Then keeping A and Q on a line, we will draw a line AC and angle CAB is of 60 degree. Next is to draw an angle of 120 degree using compass. We will draw again a ray PQ. After that with P as center we will draw an arc which cut PQ at R. After that from R and which cut at S from same radius of arc. From S cut at T with same radius of arc. Then we will join P and S, then we will draw a ray in the same direction at an angle of 60 degree. Now if you join P and T, we will get our angle 120 degree. Next is to do an angle of 30 degree with the compass. What we will do? We have constructed the angle 60 degree. Now we will draw a bisector of OC, and this is our 30 degree angle. To draw an angle of 90 degree with compass, what we will do? We will draw a given ray AB. After that, we will draw a suitable radius A which cuts AB at S point. Now from S, we will put the one arc at P and Q with the same radius. Then we will keep the needle of the compass at P and Q, and after that we will draw an arc, and this is our perpendicular bisector, and the angle formed is 90 degree. Now to draw an angle of 45 degree with the compass, firstly we will draw a ray AB. Then we will draw an arc at A and touches AB at S. From S, with P point as its center, previously drawn arc, but we will do with same radius, we will draw arc from Q and R at point S. Then we have our angle SAB of 90 degree. Now with the same radius, what we will do? We will draw a bisector. Now we will join A with U that cuts previous arc at V, and here our angle is 45 degree. Now let's start with exercise 7.4. In the first part, you have to make an angle of the following measurement using compass. What you have to do? You have to draw a 60 degree angle. Firstly, what you will do? You will draw an arc. After that, firstly you will draw a line segment. After that, you will draw a semicircle, and then you will draw an arc, then again an arc, and then you will meet it, and this is our 60 degree angle. That's how you can complete the remaining part. Next is our triangles. Let's start with the classification of triangles on the basis of sides. A triangle is a polygon with three sides and three vertices, and sum of angles is 180 degree. Scalene with unequal sides, that means all the sides are unequal. Then XYZ is a scalene. In example number 13, which of the following is a scalene triangle? Very good, that is option number 1, because it has all its sides unequal. Next is our isosceles, in which any two sides are equal, that means PQ is equals to RP. Now here we have to state which of the following are isosceles triangle. In this one, that means figure 1 and 2 are isosceles because both of them have two sides equal. Next is equilateral triangle, in which all the three sides are equal. This is our equilateral triangle. Here we have to state which triangle is equilateral. So first one is an equilateral because all the three sides are equal. Second is not, because all the three sides are not equal. Now here we are classifying triangles on the basis of angles. First is our right triangle, that means which has one of its angle as 90 degree. So angle C is here 90 degree. So ABC is a right angle triangle. Next is our obtuse triangle. An obtuse triangle is a triangle which one angle as its obtuse, that means one angle is greater than 90 degree. So here angle A is obtuse, and this is our obtuse angle triangle. Now example number 16, here we have to state whether which of the following are obtuse angle triangle. So here figure 1 and 2 both have angle greater than 90, so both are obtuse angle triangle. Next is our acute triangle, in which all the three angles are less than 90 degree. So ABC here is our acute triangle. Example number 17, we have to state which of the following are acute angle or not. So first one and second one both are acute angle because both have angles 90 degree in both of them. Some properties of triangles. First is our angle sum property of a triangle. The sum of three angles of every triangle, that is 180 degree. That means angle A plus angle B plus angle C is 180 degree. In example number 18, PQR is our what? Equilateral triangle. We have to find a measure of all its angle. That means all the angles are equal and equals to 180 degree. So that means all the angles are of 60 degree each. Next is our exterior angle and interior opposite angles of a triangle. Here we are considering a triangle ABC and we will produce the sides BC to X and ACX is called the exterior angle. Similarly, we will produce side CB to Y and ABC is an exterior angle of triangle ABC at B. ABC here angle number 3 is called the interior adjacent angle, and angle B and angle A are our interior angles for angle ACX at C. Similarly, angle 2 is the interior adjacent angle for angle B and angle C, and angle BAC is the interior opposite for angle B. Now let us find a relation between the exterior and the interior angles of a triangle. So angle 1 and 2 and 3 angle sum property, that is equals to 180 degree. Now we know that by linear pair angle 3 plus ACX is equals to 180 degree. So that means angle ACX is equals to angle 1 or angle 2. That means exterior angle is equals to the sum of its two interior opposite angles. Now we have the following, that in a triangle an exterior angle is equals to the sum of its two interior opposite angles, and an exterior angle is always greater than either of the two interior opposite angles. Now next is our triangle inequality property. So here it has three sides, triangle ABC, AB, BC and CA. For a shorter notation, what we have written that opposite side opposite to vertex A is A is equals to BC, B is equals to C and C is equals to AB. So here the measure of length A, B and C, we find the following relation: A plus B greater than C, B plus C greater than A and C plus A greater than B. Now we have the following, the sum of any two sides in a triangle is greater than the third side. In example number 19, which of the following can be the possible length of a triangle? That is 3 plus 5, that is 8, greater than 3, greater than 3, greater than 5. That means these can be the length of the sides of a triangle. In the next one, it is less than 8, then it cannot be the length of sides of a triangle. Now the altitude of a triangle. Before studying altitude, let us know about the perpendicular lines. We know that L, M and N are what? Perpendicular lines, and an angle measured by them is 90 degrees. So we can say that N is perpendicular to M and P is the midpoint of AB. So line N is a perpendicular bisector of line segment AB. Now always remember, two rays or two line segments are said to be perpendicular if the corresponding lines or segments by them are perpendicular. For example, the foot of table is perpendicular to the surface of the table. So here the perpendicular line that is drawn from the vertex of opposite side, that is this opposite side, this is our what? This is our altitude, and AL perpendicular to BC. So BC is the base and AL is the corresponding altitude of ABC. Now always remember, there can be one perpendicular from each vertex of a triangle to the opposite side. Then there are three altitudes in a triangle. First is the median of a triangle, a line segment which join a vertex of a triangle to its midpoint, that is called the median. In this figure, AD is our what? AD is the median and BD is equals to DC. So a triangle has three medians. Now in example number 20, in the given figure, we have to name the altitude and median of triangle ABC. So in this figure, AD is perpendicular to BC, so AD is the altitude and CE is the bisector. So EE is equals to BE and CE is what? The median of triangle ABC. Let's start with exercise 7.5. In the first part, we have to state whether the triangle is a scalar or not, and measures of side are given below. So first one is a scalar triangle. That's how you can complete the remaining part by yourself. Next is chords. Here we have given that O is a point in the interior of triangle ABC, and we have to state which of the following statements are true or false. Give reason in support to your answer. So we have told that OA plus OB is greater than AB. That is a true statement. That's how you can complete the remaining one. Now let's start with quadrilaters. In a quadrilateral family, each member has four sides, four vertices and four angles. Classification of quadrilateral: trapezium, having exactly one pair of parallel sides. In the given figure, ABCD is a trapezium and AB is parallel to DC but not parallel to AD. Now always remember, an isosceles trapezium is a quadrilateral having exactly one pair of parallel sides and non-parallel sides of equal length. That means AB parallel to CD and the another one is equal. Parallelogram, a quadrilateral which have pair of both sides, opposite sides parallel. In the given figure, ABCD is a parallelogram and AB is parallel to DC and AD is parallel to BC. Now in example number 21, we have to state which of the following are quadrilateral. First one, no, it's a triangle. Second, yes, four sides are quadrilateral. Third, no, it's a hexagon. Fourth one is yes, it's a quadrilateral with four sides. Now in example number 22, how many trapeziums can be found in this figure? 3 trapeziums, and these are the 3 trapeziums. Now in example number 23, from the adjoining figure, we have to state which of the following are true or false. So first one, AB is equals to DC. Yes, true, because opposite sides of a parallelogram. AB parallel to BC. False, because adjacent sides of a parallelogram can never be parallel. Angle A equals to angle C. True, because opposite angles of a parallelogram are equal. Next is angle ABC is equals to angle BCA. No, because adjacent sides of a angles of a parallelogram are not equal. Rhombus, a parallelogram having all sides equal, that means all the sides are parallel and equal. Rectangle, a parallelogram in which each angle is a right angle is called a rectangle. So here ABCD is a rectangle in which the opposite sides are parallel and equal, and diagonal AC and diagonal BD are at right angle with each other. Example number 24, how many rectangles can be found in the figure? We have to name them. So there are 9 rectangles, ABCD, AGHD, GBCH, AEFB and so on up to IHDE. Now square. A square is a parallelogram having all sides equal and all angles at right angle is called a square. For example, ABCD is a square in which these sides are parallel and all the sides are equal and all the angles are of 90 degree. Here is the identifying features of a quadrilateral. Rectangle, parallelogram with all angles right angles. Square, rhombus with all angles right angles. Rhombus, parallelogram with all sides equal. Parallelogram, a quadrilateral having 2 pair of opposite sides equal and parallel. Kite, a quadrilateral having 2 pairs of adjacent sides equal. Trapezium, a quadrilateral having 1 pair of opposite sides parallel. Then is our isosceles trapezium, or trapezium with pair of non-parallel sides equal. Exercise 7.6, in the first part we have to name the quadrilateral and satisfy the description. Opposite sides are parallel and all sides are equal, that is our very good rhombus. That's how you can complete the remaining parts. Now let's start with the polygons. A polygon is a plane figure that is made by joining the line segment where each line segment meet exactly 2 other line segment. So the intersection point of 2 line segment is called the vertex of the polygon. So the types of polygon are classified into according to their number of sides. 3 triangle, 4 quadrilateral, 5 pentagon, 6 hexagon, 7 heptagon, 8 octagon, 9 nonagon. Example number 25, here we have to classify the polygons according to the sides. First one is a pentagon, second is a nonagon, third is a quadrilateral and fourth is a hexagon. Example number 26, in the adjacent figure, the polygon according to its sides is octagon because it has 8 sides. Regular polygon, if all the sides and angles of a polygon are equal, then it is a regular polygon. These all are our regular polygons. Irregular polygons or non-regular, that means which has all the sides are not equal. So scalene triangle, rectangle and pentagon are irregular. Exercise 7.7, in the first part, which of the following closed plane figure are not polygon? First one is not a polygon, that's how you can complete the remaining part. Next is our chapter and exercises. In the first part, we have to take the correct option. Number of right angles in a complete angle is 4. That's how you can complete the remaining part. Mental math, we have told that each of the 2 angles of a triangle is 5 by 8 of third angle. Here we have to find degree measures of all the angles. So 5 by 8 of third angle. Firstly, you will given that 2 equal angle of a triangle. That means if we have angle A, angle B and angle C, then angle A is equals to angle B. By using this, plus angle C is equals to 180 degree. After using this, you will find angle A and B and then you will find angle C. Here is our odds and assertion and reasoning that you have to solve it by yourself. Now I hope you have understood the chapter pretty well. You just have to practice exercise question and don't forget to revise this topic again.